At Custom Mold, we manufacture brass blade baffles for the most reputable component suppliers and end users in our industry. Our brass baffles with XT technology are the highest quality available, offering time-tested durability and performance. Over the years, several plastic baffles have been introduced. Being molded, they claim cost benefits, and some even claim improved cooling. Initial cost savings, in fact, are minimal, and today's mold makers know they can't ship quality molds if they use inferior components. Recently, another plastic baffle has been introduced, claiming to create turbulent flow and offer 20% improvement in cycle times. At Custom Mold, we tested these baffles to confirm they would perform as advertised. Our investigation found their tests were based on the assumption that brass baffles have to be 40 thousandths smaller than the waterline to be installed. This is simply not true. We installed 2 of our brass baffles in a test fixture containing 3 identical cooling channels. In the third channel, we put a baffle with 20 thousandths clearance per side to duplicate their test. As can be seen here, any baffle deliberately undersized this amount will show most of the coolant leaking past it. We can also observe the brass baffles flowing clear to the end of the channel, even at only 1/4 gallon per minute of flow. In fact, brass baffles are made to fit within 2 thousandths of the channel wall along the entire length of the cooling channel. They are then precisely assembled to rotate within 5 thousandths TIR of the tapered pipe thread. We then tested the most important part of any blade baffle, the pipe plug. We threaded a steel test hole and carefully gauged the 3/8 NPT thread for size, taper, and depth. We installed one of our brass baffles with patented XT forged plug into this hole to a preset torque. The plug was then tightened further to orient the blade and ensure a tight seal. We then put the plastic baffle in the same hole at the exact same torque. The plastic plug compresses so easily it never becomes tight. The correct sealing torque is uncertain and is left to the feel of the installer. Due to compressive creep and stress relaxation, plastic pipe plugs can loosen in time, and this loss of torque can affect the seal. The plastic blade has very little strength and is brittle. When the plastic blade is installed, it must be forced into the channel to break down the oversized area of flash on the blade. This flash breaks down as it is installed, basically sizing the blade. The plastic blade has very little strength, so installation is not precise. The weakness of the plastic and the friction of the plastic flash make the final alignment of the blade uncertain. Even a small imperfection in the cooling channel can stop the plastic blade from rotating altogether, and the mold maker would not know it. When removal is required, the plastic baffle is completely destroyed. Even the manufacturer requires every baffle be replaced with a new one after every use. With XT brass baffles, removal is assured, even with an impact wrench, and the baffle is ready for reuse. We then assembled brass and plastic baffles into identical holes with all blades the same length, creating a fair and valid comparison of both products. As even a slight trickle of water is introduced, we see that the baffles perform the function of moving coolant into and out of the holes. Since the Reynolds number at this flow rate is below 2500, the flow is laminar. As we add air to the flow, it is easy to see the baffles performing equally. The spiral blade does enhance cooling by creating a longer, balanced cooling path. What is not present is any indication of increase or turbulent flow by the plastic baffle, as its manufacturer claims. To check if flow is turbulent, we can calculate the Reynolds number. For water in a controlled environment, we can use this formula. Since the kinematic viscosity and density of water are constants at a given temperature, one can quickly see turbulent flow basically depends on the velocity of the fluid, V, and the channel size, D. By increasing the velocity, we can cause the water to become turbulent. Only by increasing coolant speed can we raise this number. As we increase pressure to the system and the flow rate increases to 5 gallons per minute, we see again all baffles performing the same. The air added for this test shows the flow characteristics of all the blades to be exactly the same. At this flow rate, the Reynolds number exceeds 40,000, so we know the coolant flow in all channels is turbulent. As we remove air from the flow, we see again all baffles performing the same. While over the decades, there have been plastic baffles introduced claiming better performance or lower prices, the ultimate value is in a cooling component that is properly engineered and quality manufactured. For a production mold, predictable and reliable cooling is essential. For your production tooling investment, look to custom mold solid brass XT baffles to consistently deliver performance you can trust.